friends, today I'm going to solve LeetCode problem number 744, find smallest letter greater than target. So in this problem we are given an array letters. This array consists of array of characters and this array is sorted in non-decreasing order. Alright, non-decreasing order means that the values are either increasing or are the same. Okay, and we are also given a character target. Now, what are we given also is that there are at least two different characters in these letters, and now we need to return the smallest character in the array that is lexicographically greater than target, which means that we need to return the character which is larger than target. Okay, and that character should be the smallest of the largest characters, and if such character does not exist we are going to return the first character. Okay, now let's look at this example. So we have this array and we are given the target a. So what are the values greater than a? Since this is in lexicographical order, if we use brute force search, then we would start from the first, right? Because the first one will the smallest one. So we check, is C greater than A? Yes, C is greater than A, and that is the first element, first character which is greater than A, right? So we found the smallest one, which smallest character which is greater than A, and we return that. Now here in this case also we are given the target C, and we need to find the smallest character greater than C. So since C is equals to C, that is not our answer, so we move on to the next one. And now C and F, and we know that F is greater than C, right? So this will be our smallest character greater than C. Now what about this case? So in this case we have the character Z, and our letter array is this, and we know that like Z is the largest character, right? No other character is greater than Z, but we still need to like perform our operation. So we start from the first one, we check with X, and then it's not greater, so we move on to the next one. It's still not greater, we move on to the next, and the next, and then finally we have like checked over all of the characters and we found that no letters are greater than Z, so we just return the first character which is X. Okay, so this was a brute force approach where we started from the first index, we checked, compared that element with our target value, and if that was not equal we moved on to the next one until we found an equal value. If we did not find an equal value, then we return the first element. Okay, so that was a brute force approach, and brute force approach means in the worst case we are traversing all of the elements. Okay, so that would be a time complexity of O of n if there are n number of characters in our letters array, right? Because there is a possibility of having a number of characters, because it doesn't say that it doesn't have any duplicates. It has duplicates, as you could see here, and then duplicates could repeat as many times, n number of times, right? So here we are given the length is at least 2 and is maximum 10 to the power 4, and our lowercase English letters only, and it's sorted in non-decreasing order and contains at least 2 different characters, and target is a lowercase English letter. Okay, so that was a brute force solution that I explained just now, and which is of n time complexity. So can we solve it in a much better time complexity? Well, yes, of course we could solve it. How could we do that? Let's look at this problem statement once again. So we are given the array of characters and we are said that it's sorted in non-decreasing order. So once we hear the word sorted, it's always applicable for us to use binary search, because binary search can only be implemented on arrays which are sorted. So here we could implement our binary search. Now how are we going to implement our binary search? So we need to find the smallest character which is lexicographically greater than the target. Okay, so let's take this example and I'll tell you how we could approach our solution. So we have this example here, and now in binary search we have a left pointer and a right pointer, right? So I'm going to define my left and right pointer. So now we are going to find our middle value, and middle value here is this one, as we only have three characters. So left is at index 0, right is at index last index, and middle is the index value 1. And now we check, is target A greater than or equals to M? What's the compare it? When we compare, what do we get? We get that M is greater than A, right? But what do we need? We of course need a value which is greater than A, but the smallest one, right? Smallest value which is greater than A. So what are we going to do is, let's just think intuitively. Okay, so if I found a value which is less than A, then what should I do? I need a value greater than my target, right? So if that value is less than my target, then should I go towards the left or towards the right? Of course I should move towards the right, right? Because towards the right I can find the values which are greater than A. So if middle value is less than target, move to right. All right, now what if middle value is equals to target? We are still moving to right when middle value is equals to target, because like target is, our goal is to find smallest character lexicographically greater than target, right? So if we found the character which is equals to target, which means that there is a character which is greater than the target towards its right. So that is why we need to move to the right again. Now what if the value at middle is greater than target? So what do we do? Okay, so if the value at the middle pointer is greater than target, let's suppose our target is equals to A and the middle value is equals to let's suppose E, then what do? We in that case we move our pointer towards the left, because there could be case where like we have a value which is greater than A but less than E, right? Like for example, we have something like A, C and E. Now if in this case my middle pointer is at this index, that is at E, I still need to move towards the left, right? Because like I can see, you could see, right, towards the left I have this value, this is the correct answer, so I need to reach here. So how can I reach here? By moving my right pointer towards the left. So that is what we are going to do, we are going to move towards the left. Okay, so this is how we are going to perform our binary search. Now once we have reached the pointer, like once we have moved my pointer towards the left, okay, so let this be right. We are moving to the left means we are moving right pointer to the left. Okay, so we are moving to the left half. So in this case my right pointer is here, and now my left pointer, let's suppose my left pointer is still there, and now my middle value, where would my middle value be? Will be here, right, where my left is pointing. And here in this case it's equal, right? And the target equal to target, since it is equals to target, we move to the right. So that means now my left pointer will move here. So now left and right are at the same point, and my middle pointer will also be at pointing to the same value. Now this value is greater, right? Since it is greater than the target, we move to the left. So we are moving to left means we are moving the right pointer to left. So now my right is here and my left will still be here. Now what happened is left left becomes greater than right. The index of left is greater than right, so in that case we stop right there and then we return the index of left. So what is the value at in left index? It is equals to c, and that's our correct answer, right? Since we are looking for target a, so that is our correct answer. We return that. Let's look at this case. So our target is still a here. Now our middle value is f m, which is equals to f, and f is greater than target. F is greater than a, so we move to the left. So while we are moving to the left, right is equals to m minus 1. We do that. Now our left right is pointing the same, so our mid will also be pointing to the same, which is equals to c. And here in this case, now since it is equals to c and c is greater than our target a, right? So we again move to the left, and while we are moving to the left, now what happens is okay, I'm just going to do it like this. So our left pointer will still be here, but now our right pointer is somewhere around here, and that value is now equals to -1, which is less than my left pointer. So at that point we just stop right there and we return the value at our left index, which is equals to c, and that's our answer, right? So that is how we are going to solve this. Now I hope you understood the algorithm. Let's dive into our code. So let us define our left pointer, which is at index 0, our right pointer, which will be the last index, so that is letter dot length -1 letters at length -1. And now for let I, okay, we are going to use while loop. Since this is a binary search, we use a while loop. While left is less than equals to the right, what we do is we calculate our mid value. So mid is equals to math. We are always taking the floor value of left plus right divided by 2. And now we are going to check for these cases. Okay, so if mid is less than equal, if it is less, we move to the right. If it's equal, we all move to the right. So I'm going to do check that if the value at mid, so letters at mid is less than or equals to the target, then our left pointer is equals to mid -1. Now else we would change our right pointer equals to mid. This would be -1, this would be +1. All right, and finally we return left. Okay, let's try to run our code. Okay, so we actually need to return the character at that index. TTR's letters at index left. Now let's run our code. Okay, we got, so what did we do wrong here is we missed one thing. So if the character does not exist, we have to return the first character, right? And in this case we it doesn't exist. In this case our left pointer will go out of bound, and that is why our output is undefined. So for that case we need to check if left pointer if left is equals to mid, equals to left, okay, equals to the length of the letters, then we return letters at index 0, else we return the letter at our index left. Okay, letters. Now let's run it. Awesome, let's submit this. Great. So the time complexity of this solution would be O of log n because we are using binary search, and the space complexity is constant in this case. So I hope you like my solution. Let me know in the comments down below. Thank you.